Today we are going to learn one of the most powerful tools of algebra, which is completing the square. And this tool can be used in different topics throughout mathematics. Some of them are here, like solving quadratic equations, then finding inverse functions of quadratic functions, then finding turning points and deriving quadratic equations. So let's master this tool. Now we already know that the quadratic expression is given as x squared plus bx plus c. This is the structure of a quadratic expression. Our target is to convert this quadratic expression in this format: x plus p whole square plus q, and p and q must be numbers. Now we know two formula, algebraic formula, a plus b whole square. If we have a plus b whole square, how can we write it? A square plus twice ab plus b square, right? So first of all, we are going to convert this quadratic expression to this one and then convert it to that one. And eventually we're going to find a constant plus q with that one. So the idea is we are going to convert the quadratic expression x plus a square plus bx plus c from that format to x plus p whole square plus q, where p and q will be numbers. And to do that, we are going to convert that quadratic expression to that format. Then using this formula, we are going to find our a plus b whole square. Now let's see some examples and let's see how actually we can convert like that. So let's start with a basic example. We have x squared plus 2x plus 3, which is a quadratic expression. Now our target is to convert it to completing square format, x plus p whole square plus q, right? Remember, we want that formula. We want these three terms in our solution here so that we can convert it to our square format. Now, when we start, we're going to focus on the first two terms only. And we will, using the first two terms, we will try to match this format, a square plus twice ab plus b square, because our target is we want to convert it to this one, a plus b whole square. We need a square. So what can we do? The first thing we need is a squared, and we have that one. We already have x squared, right? Then we need 2ab. We have 2 already. We have 2, so we don't need anything else. Now we need a. A is what? Whichever the term square was, the a. So we have x squared already. So as a, we are going to use x. Now we need a b. We have to use a number that gives us b, right? And then we'll put b squared. The problem is I have to choose this number very carefully. I have to choose a number that does not change our term from the middle term of the quadratic expression. What's the middle term of quadratic expression? 2x. Whatever number I put as b here must not change this term from that one. Let's say if I put 2 here, we have 2x already. If I put 2 there, I'm getting 4x, which is different from the middle term. So I cannot put 2. So what should I put here so that it does not change from here? We should put 1, right? So now if you multiply 2x and 1, you still get 2x. So nothing have changed, but you have found your b. Now when you have your b, you need a b squared. So we just put 1 square in there. But this guy is an intruder, right? He doesn't belong here. So we have to subtract that thing to neutralize the situation. This is the term I took extra. That's why I subtracted it so that it does not hamper our lines, okay? Now I had a constant plus 3. It stays there, nothing else. So what we did actually, we choose our b, and then that b goes to b square. Because it is extra, we subtracted it to neutralize the situation. That's it. Now what does that do for us? Look at the first three terms. We have a squared plus twice ab plus b squared. So we basically have a plus b whole square. That means we have x plus 1 whole square. Now let's look at this one. We have minus 1 square is 1, and then we have plus 3. Let's keep it like that. And we can easily calculate x plus 1 whole square minus 1 and plus 3. That gives us 2. Now see, it has successfully been converted to x plus p whole square plus q. Okay, so this is p, this is q, p equals to 1, q equals to 2. And just like that, a quadratic expression has been converted to square terms. Now this is a very basic example. Let's solve some other examples and see if the question is complicated, how we can solve them. Now let's look at our second example. We have x squared plus 6x plus 4. Now The first thing we should do, we need x square, a square. We already have it, right? Now let's focus on the middle term. What do we need? We need 2 twice ab, right? So 2 must be there and a must be there. What's our a? We already have the a, which is x. Now we need a b. What was the condition? Whatever number I put there, it must match with that one, right? So we must match 6x. We have 2x, and then we have to take b as 3, right? If we take 3, then when we multiply, you get the same thing, 6x. But if you put another number in there, we are not going to match the middle term. So the only number you can put there is 3. Now 3 has been converted as b, right? When we have b, we have b squared, 3 squared. Now again, this is an intruder. It does not belong here. So we have to neutralize the situation. We added this one extra. So we're going to add this one, subtract this one to neutralize the situation. And our 4 was there. So we have to put the 4 here. Again, if we take first 3 terms, we have the formula a square plus 2xab plus b square, which will give us x plus 3 whole square. And then you have 3 square, which is 9 plus 4. When you solve it, you get x plus 3 whole square minus 5, right? So according to the format, x plus p whole square, then plus q. So the value of p here is 3 and value of q here is minus 5. Remember, this is minus 5 because the format was plus q, then we have minus 5. So we have to just use minus 5 in there as a value of q. Now let's move on to our third question. By the way, if you need help with chemistry, there is a whole playlist of chemistry contents too. You can just press on the I button and check out that playlist too. I think it will be very helpful for you. In our third example, we have x squared plus 7x minus 2. It looks exactly the same, right? But there is a catch. Let's solve it. Again, we need a square. We already have a square. We need a 2 twice ab, right? So 2 must be there. And we have the a, which is x. Now we need a b such that it stays the same with the middle term in there. So we cannot put any full number in there, right? We cannot put 1, 2, 3, 4 because nothing multiplied with 2 will give you 7. So what can we do here? In these cases, when we cannot just multiply something and match the middle term, we have to consider fractions. What fraction can we put here and get 7? We can put 7 divided by 2. In that case, you can just divide this 2 by that 2 and get 1, and again it becomes 7x. So problem solved, right? So when we cannot multiply a number integer with 2 and get the middle term, then we have to use a fraction. Okay, now we have our b, so this is our b square, and this is extra, so we have to subtract it, 7 divided by 2 whole square, and we have our constant in our expression, so we just use it. Now again, from here to here, this 3 terms is going to give us that formula a plus b whole square. So a plus 7 divided by 2 whole square, then we have to calculate the remaining part. So 7 square is 49, 2 square is 4, minus we have 2. Now let's calculate and find the solution. X plus 7 divided by 2 whole square, we already have the value of p, we just need to find the value of q. Okay, now just LCM it, 49 minus 8, and you are going to have your answer, x plus 7 divided by 2 whole square minus 57 divided by 4. So the value of p here is 7 divided by 2, and value of q equals to 57 divided by 4, minus 57 divided by 4. That's it. So even if your middle term does not match with 2x, that means it's an odd number, you can still use a fraction and solve your completing square. Now let's move on to our next example. Now what if our square term has a coefficient like this one? We have 2x squared plus 3x plus 1, but now without x squared we have a number. Let's solve this one. So first of all, we have to remove that number because we want the format a square plus 2ac plus b square. There's no number with a square. We have 1, nothing other than 1, right? But we have a 2 here. So first thing we're going to do, we are going to divide the whole expression with the coefficient so that this 2 is removed or the coefficient is removed. So if we take out 2, we have x squared, then we have 3 divided by 2x, then we have half, 1 divided by 2. Now, next thing, we follow the same procedure. We have a square, we need 2ab, so 2 will be there obviously, 2a is there, and we need a b such that it doesn't change. Now, in this case, whatever you're going to do is going to write the numerator and only care about the denominator. What denominator gives you the same number? If we put 4 in there, we can just divide this 4 by 2 and we're going to have 3 by 2 again. So that's it, done. Now if you multiply, you're going to get the same thing, 3 divided by 2x. So you have your b. Now there it goes, b square, 3 divided by 4 whole square. We have to use the second bracket there, that we are using a first bracket again inside. So this is extra, the intruder, so we have to subtract it again. So we have 3 divided by 4 whole square subtracted, and our constant in there, 1 divided by 2. Okay, so that's it. This 2 stays there, no problem. So 2 in there. Now you have, using these first 3 terms, you can easily write that formula, a plus b, 3 divided by 4 whole square, then minus 3 square is 9, 4 square is 16, you have half, 1 divided by 2. Okay, let's close it. Now we are going to calculate that part. We are not done yet. So x plus 3 divided by 4 whole square. Okay, simply what you're going to do is take the denominator, LCM, then you have 9 and plus 8. So close it now. We are going to get 2 x plus 3 divided by 4 whole square minus, we have minus 1 divided by 16. Okay, but we want the coefficient only with the square term, not with that term. So we are going to get it out. When you get it out, remember 2 is multiplied with also this one and that one. So when you get it out of the bracket, you have to multiply 2 with that one. So finally, what we are getting is 2 into x plus 3 divided by 4 whole square. Then when you get 1 divided by 16 out, you have to multiply 2 with it, because 2 is multiplied with that one. Now we are getting it out of this boundary, right? So minus 2 multiplied by 1 divided by 16. You're going to finally get your answer, x plus 3 divided by 4 whole square minus 1 divided by 8. If you just follow the procedure, you'll be able to find any completing square term for quadratic expressions. It's going to be very helpful for our next video, where we'll be learning inverse function, how to find inverse function. If you did not watch the function videos yet, you can press on the I button and watch them. I'm sure that they're going to help you a lot. So this is it for today. See you in my next video. Until then, bye bye.